Hello, in this video we'll talk about the electron configurations of transition metal ions and the radii of ions. Okay, first up, transition metal ions. This is a little detail, but a detail you need to know is that when a transition metal, in this case we're showing cobalt, when a transition metal ionizes, the order of the energy levels changes. So the 3D, which was normally higher energy than the 4s, the 3D drops below the 4s, and so now the order of filling changes. So you'll fill the 3D, and then the 4s in the cobalt ion on the right is pretty much always empty. So another way to show this is when you have a cation that's formed from an atom of a transition metal, electrons always come out of the s orbital first, and then they'll come out of the d orbitals. So some examples here. So manganese, in its normal neutral state, is 4s2 3d5. Now, when you make manganese 2+, you get 4s0. The electrons come out of the 4s, and then, since you're only taking 2 electrons out, you still have 3d5. Now when you go to manganese 3+, okay, 2 of the electrons come out of the 4s, and then 1 of them comes out of the 3d, so now you have 3d4. And then manganese 4+ is the same thing, right? You'll get 2 electrons out of the 4s, and then 2 electrons out of the 3d. So how you need to write them on the test is by omitting this 4s0, because that's something we omit by convention. We don't write all the orbitals that have no electrons in them. So then you'll just say argon 3d5, 3d4, 3d3, etc. So it's a pretty straightforward concept. It's just another thing that you have to know. So definitely put the time in to learn it and you'll be set. So also pause the video, practice these problems, and then I'll put the answers up in a second. Alright, so vanadium, in its neutral state, is 4s2 3d3 after the argon, noble gas. Now, when you go to make an ion out of vanadium, the 2+ ion is going to lose these 2 electrons right here. And so you'll have just argon 3d3. Now, when you go to vanadium 3+, then you lose one of the electrons out of the 3d, and it becomes 3d2. Okay, so that's what we're going to learn about transition metal ions and electron configurations. And then the last thing in this chapter is the radius of ions. So this is something you need to know, that when you go from a neutral atom to an ion, that the radius changes, and I want you to know whether it gets bigger or smaller. And that's the extent of which we're going to look at this. So if you add electrons and make a negative anion, the radius increases. The reason here is that if you have more electrons, there's more repulsion between the electrons and a larger electron cloud. So that means the electron area gets a little bigger because the electrons tend to repel. Another way to think of it is that you have more electrons for the same positive nuclear charge, so the effective nuclear charge felt by each electron is lower, and thus it can't pull it in as tightly. Ultimately, you can think of it like you had a bag. You put more electrons in the bag, it's going to get bigger. Okay, when you remove electrons, the radius decreases. The easy thought here is you take electrons out of your bag gets smaller. Really what happens is the reverse of the logic before. You have less electrons, therefore the core of the atom on average can pull more strongly on each electron, and then the nucleus pulls the electrons closer. So on the left we have positive cations from the alkali metals, and so here you have the neutral atoms, and then when you remove an electron, the radius becomes smaller. Then on the right side we have the halogens, and then when you add an electron to the halogens, the radius gets bigger. And then these images also show the trends that we learned previously for radius. As you go down the periodic table, your radius gets bigger, and that's also seen here. Here's a nice chart that shows various radii of a bunch of different elements and their ions, and it adheres to the same trend that we just discussed. And another example, if you look at copper, okay, neutral copper is 128 picometers is the radius. Then when you go to copper 1 plus ion, it gets smaller to 77 picometers. And then when you take another electron out, it gets even smaller, which makes sense given what we just talked about. And so I'll leave this as the pre-quiz question. Select the species with the largest radius. Okay, and that's what we need to know for the moment. So thanks for watching, and I'll see you again.